If I give you a power curve, how will you find out minimum drag speed? You can draw that, that's fine.
Yes, sir.
Power is equal to drag into CAS, and we have derived power curve, if you remember, power curve.
Yes, sir.
How will you find out, so what is the minimum, the speed corresponding to minimum power?
VMP.
VMP, and why is that significant?
Because we have a maximum duration.
That's right, when you fly at minimum power, you have minimum fuel consumption, therefore the entrance is going to shoot up, max entrance. You'll see it again. But if I want to find out minimum drag speed from a power curve, minimum drag speed is available from the thrust required curve directly, not from the power curve. How will you find out?
By drawing a tangent.
Oh, very good. By drawing a tangent. Yes, you take a scale, you fix the scale, one of the end of the scale here, you start moving. The moment the scale touches the curve, that's the tangent. So basically, it's somewhere here.
And VMD is always greater than VMP.
That's right. VMD is always greater than VMP. Okay, so tangent to power required curve will give you the minimum drag speed, or VMD. We have seen this before. This is VMD, yeah? It's V and P, right? Now what happens if you have wind? So say for example, if you have wind, there is a certain amount of wind component that you have to consider. This is a wind. Now wind is connected to speed, right? Therefore it's more towards the true airspeed, but it affects the indicator airspeed as well. Therefore, when you have a certain amount of wind, that is actually in line with this indicator airspeed. Now you have to draw the tangent from somewhere down here, right? So now we again take a scale. Now if you start drawing tangent, the tangent is probably going to hit the curve somewhere here. So you see, when you have a headwind, you have to now fly faster at an increased VMD. This is a graphical representation, but you see it is not very easy to understand it from this. That's why you can think about the fact that if I have a headwind, I want to stay lesser in the headwind. Therefore, I can minimize the effect of headwind. To fly less, to stay lesser in the headwind, I have to fly faster. And you can see I have to fly at a higher VMD. I have to fly faster. That's why we are saying that the V is going to be greater than the normal minimum drag speed in nil wind condition in a headwind. Or same thing in a tailwind as well. It's going to be less a tailwind. We want to consider the tailwind towards this side. Now if I draw a tangent, the tangent is going to hit the curve somewhere here. And you see how now the VMD in a tailwind is lesser than the VMD in nil wind conditions. I have to fly slower in a tailwind to maximize the effect of tailwind on range. I have to fly faster in a headwind to minimize the effect of headwind on the range. It's graphical representation. If it's confusing you, just leave it. As long as you can understand it conceptually, which we discussed earlier, that's enough, right? Yes, let's look at the option.
Can you just click a pic of the board?
Say again?
Can you just click the pic of a board and send in the group?
Isn't it still clear? Or is it?
No sir, actually it is stuck for me again and again, so I am not able to draw it.
Oh, by the way, how is the board now? Is it fine for you, Anuj?
Board is clear.
No, because
it is just,
yeah, I understood. What I was asking is board was not clear earlier, right? I was asking then.
yes, now it is clear.
Yeah? Yeah, I was an effect, yes.
Just both the graphs.
I'm recording it for you anyway, so it's okay.
Okay, thank you sir.
Did you understand the effect of wind on range?
Yes sir.
And how to compensate for that? By flying faster and by flying slower?
Flying faster in headwind.
That's
and
right.
Flying slower in tailwind.
In tailwind, yes. That's right. Let's look at, yeah, you can copy this graphs if you haven't. Yeah, the option Bravo is the effect of altitude and range, and that depends upon the type of engine that we use. So you can see altitude for maximum range depends on the type of engines. You will learn this in detail in the fuel part of your technical general. Otherwise, we will just understand as of now that the altitude dependence on range is mainly engine specific. It depends upon the type of engine that you use, right? So generally, manufacturers or probably the airlines for specific, they come with a speed which is called as a long range cruise. So earlier in your navigation syllabus, they had this. They used to ask fairly good amount of questions from the performance part, where they talk about these cost indices, long range cruise aircraft for CPL. For ATPL, they still ask, but for CPL, they seldom ask. Earlier they used to ask, but now they don't ask much, right? But they have this topic. So what is the speed about? So long range cruise is basically a speed that is adopted between. This is a compromise speed between maximum range and max fuel efficiency. Right? Now think about it. What kind of a speed is VMB in comparison to VMP? It's a higher speed. So when you fly at a higher speed, your aim is to have minimum drag. But what happens to endurance? If you fly at any other speed other than VMP, lesser or more, you need more power. Remember we studied about a region of reverse command and normal command. Anywhere greater or lesser than the minimum power speed, you need more power to sustain the flight. You can see the graph is going up from there, which means I need more power is obtained by consuming more fuel, my endurance is going to fall. Therefore, when I try to fly at minimum drag speed, I might get the maximum range, but I will not get the maximum endurance. So I need both. So I come to a compromise speed, which is called as a long range cruise, especially over longer ranges. Long range cruise speed, which is a compromise between maximum range and maximum fuel. It might not give you individual maximums, but just like lift drag ratio, it's going to give you as much maximum as possible by not deteriorating the other one. Right? It's a balance between those two. That kind of a speed is what is called a long range cruise speed. Right? Now you can just Anuj, you can read Bravo, option Bravo. You're asked to find out the wrong statement. Yeah.
Okay. The altitude for maximum range depends on the type of engine speed.
Yeah. It depends on type of engine. Yeah, that's correct. Yes.
Starting commercially, a more favorable power setting called long range cruise is opted for better fuel economy and reasonably high cruising speed.
Yeah. So there's a compromise speed called long range cruise speed, which is actually a compromise between having maximum range and maximum fuel. Right? If you look for maximum endurance, you won't get good range. If you look for maximum range, you won't get good endurance. So you kind of come to a compromise speed in between, where you have the possible maximum of both. Right? Which is correct. Yes, Delta.
In tailwind, maximum range is attained at a speed lesser than VMP.
Yeah.
It is true.
It's true. Yes.
Flaps increases the maximum range at a higher VMP.
So in all these cases, you see, we're talking about range. So we have learned different graphs. To clear the air, which of the graph will you focus on when you think about range?
About range.
Yeah, when you think about range, which curve that we have studied will you look to analyze range? Drag curve, yes, total drag curve. That is why to analyze the effect of weight on range, we use the same curve here, right? So let's draw a graph again. This is between drag and indicated air speed, right? Again, this is the lift-induced drag reduces with speed, and you have the parasitic drag increasing with speed, and you have the total drag, right? This is the point where you have minimum drag speed corresponding to minimum drag, right? Now think about it. Look at option echo. It is talking about what? It is talking about the configuration of the aircraft with respect to flaps. So when you deploy flaps, when you extend flaps, what is happening to this curve? We have seen that before.
Yes, sir. Your passenger drag will increase.
Yes, flaps has, especially at higher speeds, the flap at higher flap settings, they have a predominant effect on drag. Drag has a predominant effect on the parasitic drag has a more effect on the total drag than the lift-induced drag, right? So here, the parasitic drag is going to simply shoot up. So now see, lift-induced drag is here. It has changes but kind of negligible, so I'm keeping the lift-induced drag here. Parasitic drag kind of increased all the way, and therefore what happened to the point where they intersect? It shifted from the point over here towards the left. Therefore, what is the speed now? This is the new VMD. VMD is at a reduced indicated airspeed. With the effect of weight, since lift-induced drag increases, VMD was at a higher indicator airspeed because the shift was happening that side. Here you can see the shift is happening towards the left of the original VMD. Therefore, VMD is at a reduced indicator airspeed. Right? So what happens when your VMD reduces here? So if you look at the option value, flaps increase the maximum range.
No sir, they will reduce the maximum range.
Why? Any speed other than the VMD, normal VMD, is going to affect the range. Right? When you put the flaps, it's definitely going to increase the drag. And when the drag increases, what happens to the minimum drag value? So minimum, what happens to this curve here is going to lift up, but now the increase is happening more towards
up and left.
This side, up and left, correct. So it's happening somewhere like this. Because the parasitic zone, the one on this side is the one that is going up. Right, so you can see that is why I kind of drew the minimum drag speed here. Right, now you see what is the value of minimum drag. It went up. It was initially without flaps, it was here. With flaps, it is here. So what happens when the minimum drag increases? Your maximum range crashes. Right, now you see, take for example, see, range becomes an extremely important factor when your engines go out. Say for example, you're flying and you have an engine failure. You're flying your Cessna or something, or even for that matter, if you're flying DF-42, mean like or a kind of a twin engine aircraft. So say for example, you're flying a single engine aircraft and you're flying all the way happily, and all of a sudden the engine just kind of gives away, just stops all the way. It's silence. It's like you had so much of a noise till then, and now it's pin drop silence, very calm and quiet in the cockpit. But that's one of the most scariest environment in the cockpit, when it is very, very quiet. It should not be that quiet, right? Which means the engines have gone. And now what is important? You have enough and more fuel in your wing. So endurance is not a big thing, right? You're not really bothered about how far you want to stay in the air. You're really bothered about an aerodrome that is there nearby you, and can I reach there or not? This can I reach there or not is what is more like a range we're talking about, right? And when you basically turn towards that, now the fuel is not a consideration. There's no fuel because there is no engine, so there's no fuel consumption at all. Therefore, we're not talking about this range because this range is dependent on fuel. There's no fuel question here. We're talking about whether or not you can reach a nearby aerodrome, right? When you do that, you're trying, and you can. Say for example, you believe you can reach the aerodrome. So let me put this here. So I have my Cessna here. And I see an aerodrome here. There's some checklist which you have to immediately do when you have an engine failure. You put the aircraft to glide speed, and then you do some engine failure checks. And after that, what you do is you look for field. You look at the map, you look outside for any field, not just runways, any roads, which is quite dangerous, but still you might look for it. Any kind of strip where you can actually safely land. And there are set of procedures which you have to follow. It's called practice forced landing. You'll do for your training anyway. And you see an aerodrome here. Now you see you can probably reach there, which is okay, right? Now what happens if you deploy flaps? What happens when you deploy flaps? You're increasing your parasitic drag all of a sudden. Now you have aircraft with so much of a wing area and stress camber and this so much of a drag, your range crashes. You could have made before without flaps, but you put the flaps and you reduce your range. So making a decision. Now remember, flap is also required because when you land there, this might be a farmer's field and you might not have it long enough to cater for your aircraft. So you have to stop quicker. If you want to stop quicker, you have to actually use more flaps. But you should know when to use it. Thinking that, okay, I have to use flaps for landing. If you use it here, you might not even reach the field. So first, make sure that, okay, I will reach the field no matter what. Then you can actually deploy the flaps. Don't do it straight away. Because when you apply the flaps, you're going to increase the parasitic drag, range is going to crash all the way out of the window, and the fuel range is going to reduce. And so on the other hand, say for example, you see a field, but now your field is somewhere here. Now you're too high for the approach. So you have some maneuvers which you can do. If you're still high, now you can use flaps, because that is going to reduce your range and probably make you reach the aerodrome just with the amount of distance that you have towards the aerodrome. Understood? So it's not like solid that you should not use the flaps. You have to use flaps accordingly as required, because it is having a tremendous influence on the on the range. Remember, once you put the flaps down and then if you put the flaps up, it is very, very difficult to control the aircraft, especially without engines. So once you put it down, now you cannot really play up with up and down thing. Understood? Somewhat about the effect. So what is that statement saying? Echo, flaps increase the maximum range at a higher VMD. Is that correct?
No, sir. Basically, it will reduce the range, right?
It reduces the range and therefore
lower your VMD.
It reduces range, but whatever reduced range, if you want to get maximum of that reduced range, you have to fly at this VMD at a reduced indicator airspeed. That's the meaning of this. It is going to reduce anyway, but if you want to avail that maximum of the reduced range, you have to fly at a speed that is a VMD speed which is less than the previous reduced indicator airspeed before. Right? You can draw this diagram for that for echo. This is the effect of flaps. We have drawn a similar diagram, I think, when we spoke about thrust required curves somewhere. But you can draw this diagram for echo, and you can correct that. Its flap decreases the maximum range at a lower VMD, not at a higher VMD. It's a lower VMD. Is that clear, all of you? All three of you?
Yes.
Yeah. Yes. So if you think about drag, think about this graph. Bring this graph into picture. Analyze what happens from the basics. You should be able to figure out that.
Flaps increases the maximum range at a higher VMD, but the correct statement will be flaps reduce the maximum range at a higher VMD, right?
At a lower VMD. At a lower VMD.
No, but we have to correct two things. It will decrease and it will, like the first will be decreased.
Yeah, two things are happening.
Lower, right?
Yeah, correct. It decreases the maximum range at a lower VMD.
Okay.
Yeah, the VMD is also reducing.
Yeah.
What do you call? The range is also reducing.